Hi, my name is Daniel Higgs and I'm with Forge Nano. Thank you so much for having me to give this presentation today at the SVC TechCon 2021. And thank you also to the SVC Foundation, who gave me a student scholarship several years back to attend in Providence, Rhode Island. So I'm here today to talk to you about ALD-CAP, which is our ALD encapsulation of wafers, devices, and objects. So let's get started. So today I'm going to talk about ALD-CAP technology, a bit of general background information, then quickly talk through two case studies and then the equipment that we offer that provides this ALD-CAP technology. So first of all, what is ALD-CAP? Well, ALD-CAP is our proprietary encapsulation technology that uses atomic layer deposition. Atomic layer deposition, or ALD, is a layer by layer gas phase sequential self-limiting coating technique, very similar to CVD, but better. In terms of the chemistries that can be deposited with ALD, there are a bunch of different ones. Feel free to go to atomiclimits.com and check out their ALD tool to see if the chemistry you're interested in is listed there. We do a lot of these. We do a lot of metal oxides, metals, nitrides, and we also do some phosphates and some organic materials as well. So ALD-CAP is our encapsulation technology that uses atomic layer deposition to encapsulate wafers, devices, and objects that need to be exposed to harsh environments. So the uses for that are encapsulation of semiconductor wafers for applications such as RF power or antenna, or display applications such as micro OLED or micro LED wafers. And this is for markets that include military, automotive, and aerospace mostly. Also, our ALD-CAP provides encapsulation of display panels and objects for medical devices, PCBs for consumer electronics, automotive, display, and other items that require protection from moisture and oxygen. So here on the right, we have an image of our ALD-CAP coating. It's a multi-layer coating, and this scale bar down here is 500 nanometers. So the total thickness for this specific image is about 200 nanometers. And this coating is really quite impressive. It's a flexible ceramic coating. It can be deposited down to 80 Celsius, so it's applicable for back-end wafer processes, for example, encapsulation of diced wafers or other things like that, where there may be organic containing components lying around. The ALD-CAP provides an ultra low water vapor permeability. And at 38C, that's measured at less than 10 times 10 to the minus 10, which is ridiculously good. Our coating passes the MIL STD 883E environmental endurance testing at the 200 nanometer spec. It's a versatile coating, it's non-invasive, and it can be used in addition to or in replacement of other encapsulation technologies to provide for better performance. The ALD-CAP can be used at the wafer level to replace silicon nitride cap passivation, or at the die or package levels, and it can also be tailored with specific adhesion properties to result in extremely good adhesion to different materials. And in fact, we've been able to get adhesions that are similar to that of galvanized zinc on steel, which is ridiculously good. So case study one is ALD-CAP for RF devices with Raytheon technologies. So the problem was that the silicon nitride PECVD they were using was both too expensive and not high enough performing. It was about 0.8 microns, and it just was not achieving the mil spec required. So the goal was to use atomic layer deposition, specifically our ALD-CAP technology, in the MMIC wafer fabrication process to enable lower cost hermetic packaging of their devices. So the intended outcome was that we performed work under Title III to optimize and qualify the ALD-CAP for two of the gallium arsenide processes for production at Raytheon's facility in Andover. So let's take a look at what happened. So we tested the standard existing technology against our ALD-CAP technology, both under the same conditions, which were 96 hours with a HAST or an extremely harsh accelerated testing of 130 Celsius and 85% relative humidity. For those of you that are familiar with accelerated testing, it's quite common to do an 85-85. And in terms of how we relate to that, we would be about 1,000 hours of 85-85 is equivalent to 130-85. So in terms of what happened, well, the existing tech completely failed this very harsh test. In fact, 99% of the FETs failed. When we did the ALD-CAP technology ranging from 10 nanometers to 200 nanometers, we mostly passed. I mean, we had a 97% pass rate, or higher than 97% pass, or another way to look at that is to say less than 3% failure. In addition to that, the ALD-CAP had benefits such as lower dielectric loading, better FET performance. We were able to get a 2x tighter tolerance on the capacitors because the ALD coating was so conformal and thin. And there was less variation in the actual RF properties of the FETs, which is also a great benefit of the ALD coating. Here in the table, you can see a few of the failure rates for the optical FETs and E-beam FET with the silicon nitride standard existing tech compared with the ALD-CAP. So the second case study is ALD-CAP as a Paralene replacement. So let's take a look at this. So the problem here is that many medical devices and PCBs and other objects need to withstand quite harsh conditions in terms of saline conditions or high moisture conditions or high temperature conditions. And Paralene is a standard coating that is often used to protect such devices. But in many cases, it just isn't quite good enough. It doesn't quite provide the performance that is required for certain applications. So the goal in this project was to use ALD in place of Paralene to protect devices from moisture and oxygen. And this has applications in the military, automotive, and other markets such as medical. So the intended outcome here was to beat the specifications of Paralene and produce a much more robust encapsulation technology for the ever stringent requirements of various devices. So when we compare the various properties of ALD-CAP, Paralene, and a urethane coating, you can start to see that the ALD-CAP technology really shines. It's just amazing, to be honest. The ALD-CAP compared with Paralene has a much lower WVTR, and it's not just a little bit lower. We're talking many orders of magnitude lower. Here's the number here. It's about 0.083 for Paralene C, and it's less than 4 times 10 to minus 10 for ALD-CAP. That's ridiculously good. Also, the oxygen transmission rate or the oxygen permeability is much lower for the ALD-CAP, again, by many orders of magnitude. The ALD-CAP can operate at a much higher temperature because it's a metal oxide coating compared with Paralene's or organic coating. You're not limited there. And in fact, the ALD-CAP coating can withstand temperatures above 1,500 Celsius, which makes it attractive for certain high temperature applications as well. Additionally, high heat dissipation, lower thickness, and higher dielectric constants are benefits of ALD-CAP over Paralene. So in terms of the equipment for ALD-CAP, we offer 3 main types of equipment. There is Thea, which is for R&D on single wafers, Apollo, which is for production in a cassette-to-cassette automatic robotic production system, and Helios, which is our system for production of ALD-CAP onto panels, such as display panels or large objects, or batch processing of multiple small objects. So efficiency is everything. Here, the main point is that most ALD equipment manufacturers have equipment that is inefficient. It uses more chemical than is technically necessary, and it's slower than it could be. And this can lead to, much thicker coatings deposited on the sidewalls, which can be leading to shorter maintenance intervals and higher maintenance costs, and generally a higher total cost of ownership for the user. So our solution is to use a few things that other people don't. The first is a proprietary gas handling setup. We don't have details today about that. A lot of that is confidential information, But suffice to say that we move the gases in a very novel way that enables them to get in and out very quickly while having enough time to do the ALD reaction. We also have a lot of custom components that enable us to do that gas handling, and we'll get into those on the next few slides here. So when you combine that, you end up with one of the lowest total cost of ownership systems with very high chemical utilization and much longer maintenance intervals. But the key here is that we're able to do all of this without sacrificing any of the ALD coating quality. So in terms of components that enable this extremely fast, low maintenance, low total cost of ownership process and systems, we have several key things. First, the millisecond valves, which are high-speed valves. Secondly, the high purity process controllers. We'll cover both of those on the next slide. And then also ALD sources, integrated abatement, ALD manifold that's custom, and many other small details that add up to be significant differences and differentiators with our equipment. And as I mentioned, we do all this without compromising quality. So on the bottom here, you can see the wafer-to-wafer reproducibility, and we have very high CP and CPK numbers. If you're not familiar with those, the higher the better. And then within wafer uniformity, again, we're good. Typically anything over 1.7 or so is good there. On the left here is a small chart you can kind of see if you squint closely enough. But basically this chart is saying that our systems have an extremely fast purge and they have a very high chemical utilization. So as I mentioned, the two main components that enable our equipment to be so competitive are the ALD valves. We make these ourselves. These have a less than 1 millisecond response time, which is much faster than the next best available valves that you can get from companies in the market. And also we've tested these valves for over 100 million cycles. That is 100 million opening and closing of these valves. And that was at 20 hertz. And that is the number of cycles that we can get to before the valve needs to be refurbished. And it can be refurbished. It doesn't need to be replaced. It can just be taken apart, cleaned, refurbished, put back together. Secondly, the process controllers that we have really are replacements for mass flow controllers. They're much better, and there are many details even I don't understand here, but suffice to say that combining our pressure controllers with our valves enable us to have the best equipment. So to summarize my talk, ALD-CAP technology is a Forge Nano proprietary process that is replacing silicon nitride and Paralene coatings for various applications. Forge Nano systems are the lowest total cost of ownership systems. That means the lowest dollar per wafer or lowest dollar per object costs throughout the lifetime of the equipment. And we account for absolutely everything that you would ever need to spend money on in terms of maintenance, scheduled or otherwise, facilities, labor, materials, CapEx depreciation, everything's in there. So if you're interested in hearing more about these systems or our ALD-CAP process, please reach out to us at sales@forgenano.com. So with that, I'd like to thank you so much for listening, and thank you again to the organizers of this great conference. And I look forward to seeing you all in person next year. Thank you so much.